Hello everyone, welcome to my next tutorial related to the BDF softwares. In this tutorial, we will be discuss about TDDFT, means time dependent density functional theory. It is an extension of density functional theory that help to calculate excited state properties of atom, molecules and different materials. So before start of this tutorial, I want to introduce myself who is new on this tutorial part. I'm Sahil Verma, working as application engineer in the Impulse Technology. Our company have partnership with SJW, Nano Academic Technology, and Fluxim. They provided different softwares. You can see in here for the modeling and visualizations, Chemist Device Studio, RTFF, Density Functional Theory for the material and device simulations parts, and for the quantum chemistry. In here, we are going to discuss about the BDF softwares, but we have multiple softwares, different top reputed institute using different softwares. In our previous tutorials, we have discussed about the BDF softwares and single point energy calculations and molecular orbital. In these tutorials, like you can see, time dependent density functional theory that help to calculate electronic excited state of molecules and materials. So basically, it is a extension of density functional theory, like it calculated at the ground states. With the help of various softwares, you can calculate different properties. Like why is TDFT used? So you can see different properties that have given, like UV visible absorption spectra, excitation energy, oscillator strength, electronic transitions, excited state geometry optimizations, fluorescence and phosphorescence, non-adiabatic coupling, spin orbit couplings. And you can see this type of property that calculate only the TDFT. When we move on the TDFT spin orbit coupling, TDFT non-adiabatic coupling, in the next tutorial we will be also discuss about this, but we will be focus only the TDFT. And when we calculate that naphthalene molecule TDFT parameters, so I will explain descriptions like excitation energy, that means energy required to excite an electron from the ground state to an excited state, and wavelength, it is a absorption wavelength in the UV visible spectrum, oscillator strength, intensity or probability of electronic transitions, and transition configurations, molecular orbital involved in the transitions, excited state, different excited state, transition dipole moment, magnetic and direction of the electronic transitions, and UV visual spectrum, simulated absorption spectrum of the molecules. So it is only the descriptions. When I calculated the result part, so with the data, I will explain each of the properties. So now I'm going to open that device studio where you can use PDF softwares. In a previous session, we have discussed in the device studio, it is a GUI where you can use the softwares, but BDF engine in the Linux system because BDF supported Linux. So now I'm going to open the device studio. I'm taking one of the naphthalene example. So you can click on that, create a new project and give any other name, naphthalene. TDFT. Who have not seen it my previous video, please check out that playlist of BDF. I have explained about the molecules 2D, how you can take different molecules. Like in here you can see. And if you want to create by your own selves, you can do whole periodic tables of the element given in here. And who want to study related to the device studio tabs, so different tutorials are also available. In this tutorial we will major focus about time dependent density functional theory calculations parts. So as we have taken naphthalene, so first you can go with this build tab and click on the molecule, and you can see different ring fragments given in here. So you can consider one of that, like in here that's given naphthalene structures. You can click on this, like you can apply it. So total number of atoms you can see in here, and the chemical formula that have given. And if you want to import different molecules, you can import directly from that 0D material, 1D material, 2D materials, and 3D materials. And online you can also import different materials. You can see in here the format that have given in here. And if you want to create new molecules, you can also use these tabs like they have also given. You can also move with this. Like it is a graphical user interface, but calculation will run Linux since BDF engine supported that. Now you can move with this simulator and you can see BDF. Click on this BDF, job titles, input file name, different calculation type that have given, single point optimizations, frequency optimization plus frequency, and time dependent density functional theory. Time dependent density functional theory is spin orbit couplings you can see in here, and time dependent density functional non adiabatic coupling. Different calculations type given in here, but we will focus on that time dependent density functional theory part. If you want to do, you can also do. In next video, I will discuss about calculation types. Click on this time dependent density functional theory parts, and Hamiltonian given in here you can see non-relativistic and SFS2C. So different Hamiltonians given. Different method given in here, COMSAM, Artifox, MP2. Different functions group given in here, you can see GB3, LYP. You can see in the huge dispersion corrections. That means van der Waals instructions also included. In our previous video, we have already discussed about these tabs like restricted and unrestricted. Like restricted, for that, if you want to only calculate a closed cells calculation part, only alpha parameters you can calculate it in here. And when you choose this unrestricted, that means open cells calculations part calculation you can do in here. For fast CFs calculations, you can use this different tabs, and any of that's a basic set given. I'm selecting the default parameters in here. Accuracy point of view, you can change the different basic sets. Charge depend on the users. If the molecules have the charge, you can select neutrals +1 or -1. Multiplicity, that means 2s plus 1. Electron as pair or unpaired. So you can choose like this. It is the theory parts, different solvents given in here. If you want to include a solvent effect, so you can use that tab. For the symmetry point of view, if you want to ignore that symmetry of the naphthalene, any changement, so you can do. When you move on this XCF settings, initial guess, maximum iteration, that means at the 100 times your XCF calculation iterate. Convergence threshold, very tight, loose, very loose, and DFT integral grid. So one by one they have given. If you want to find coarse, medium, and basic calculations, so you can choose level shape damping, temperatures, accelerations that help for the XCF calculations part basically. And molecular orbital representations you can choose in here if you want to do. Different formats they have given. And time dependent density functional theory parts you have active in here, time dependent density functional theory and TDA. If you want to select singlet and triplet both, so you can choose it. Just showing for the excited state. If you want to increase that excited state, you can do in here. And like we have selected that it, so you can do target states and default convergence threshold for the TDFT as well as given in here. If you want to set your excited energy window, you can set use IV method. It will work for that TDFT calculations, calculate dipole moment of the target state. So when you activate a localized molecular orbital, so they will also active. In here you can see. So different things that I've given. When you click on the previous setting, whole script that have created, and BDF as we have discussed in a previous video, they run with a module wise like compacts, geon, and DFT HCF. So first they will calculate for the orientations like symmetry wise, and after this they will move single or double electron integral and the charge and basic sets time dependent calculation after this. So one by one they will run. You can click on the generate file. You need to connect with that Linux system because calculation will run on that. So I will select as a Dell, and with the help of putty you can check the list. But before of this you need to run that BDF input file. You can click on the run button, and when you click on the putty you can type any other list. As you can set that molecule, you can add with the directory like cd, click the tab, and again check the list, and BDF C10 H10 you can see here. Again you can add with the directory BDF, click the tab. Now you can run with type BDF dot input BDF dot out. So you can type this or run your program and click the enter. Calculation has been started in here in BDF system. You can terminate this sessions, and with the when is API you can collect your result. Device Studio project Naphthalene TDDFT, so you can go with this and copy whole result. You can check different files for the orbital representations, binary files, output files, geometry files that I've given. You just need to copy this and move with BDF XCF project, naphthalene molecules, and you can paste your result in here. Click the OK button. Again, yes, you can click on the BDF output file. For the excited state, calculations has been completed in here. You can check any other show atomic number, atomic symbol, charge number, length and bonds. For the further calculations, you can collect the data and apply data when you click, so they will create a new file. You can see here the total energy of this molecules minus 381. When you click on this electron volt, so they will change. Minus, that means structure is stable. Molecular orbital representations part. Who has not seen it my previous video, please check out. I have already explained about the molecular orbital, like what is the mean of the alpha and beta and virtual and occupy. That means in the simple word we can say if some space or orbital have empty space, so it is virtual. It is a minus, so it is stable. When you click on the electron volt, you can see alpha homo energy, alpha lumo energy, and homo lumo gaps. That means EL minus EH. So they have calculated in here. It is just a representation. When you move with this TDFT, so I will major focus on this. You have selected the singlet, so only singlet calculations they have given in here, and all the symmetry they have one. So it is a irreducible representations that have symmetry levels, and excited states representation 1, 2, 3, 4. Like it is a first excited state, second excited state for the singlet. After this you will discuss about the dominant excitation. That means it is a main molecular orbital transitions responsible for that excited state, like you can see in here A33 to A35. That means electron is excited from orbital 33, which is occupied, to orbital 35, which is virtual or unoccupied space. And in here you can see exciton energy. That means energy is required to promote an electron from the ground state to excited state. That means this orbital to that orbital, so that energy will require. It is an oscillator strength. That means probability or intensity of the electronic transition. Like it range between the 0 to 1, you can say. If that oscillator strength equal to zeros, that means no photon will observe. It is a forbidden transitions or a weak peak intensity. In between, you can also show 0 to 0.01. They will range on that zero point 0.1 to 1, so high absorptions peak or strong peaks you can say. So it is just showing the strength of the electron that transfers from that one orbital to another. When you move on the compositions, that means it is a percentage contribution of that dominant orbital transitions, like means 52.5%. That means excited state is mainly described by the single transitions. If they have lower percentage, that means they have some mixed transitions. And when you move on the dipole moment, so it transition dipole moment between ground state and excited state. So in between that orbital, they have the dipole moment, 0.1, you can say. If they have the larger value, like you can see in here 2.74, that have larger value, that means they have a strong interaction with light and generally stronger absorptions. And when we move with this wavelength, it is a absorptions wavelength corresponding to the exciton energy. If they have longer wavelength, that means lower exciton energy. Like you can check on this, which 234 that have a higher wavelength in here and that have lower excitation energy. And absolute overlap integral, that means it measures the spatial overlap between the occupied and virtual orbitals, that A33 and A35 orbitals, and included there the transitions. If a value that too much close to that one, that indicate strong orbital overlap. It is just about gaps and data represent about this Naphthalene TDFT parameters. And it is theory parts. You can also check on your own point of view what is the actual meaning of this oscillator stand compositions. When you go with this like a simulator BDF, you can check UV visual spectroscopy. When you click on and check the Naphthalene project BDF.output file, and you can see UV visual spectrums file. You can also zoom like this, and in here you can see the left y-axis. It is showing the molar extinction coefficients. If they will high, so they will represent strong absorptions, and in between you can check 200 to 300 in between. They have a major absorption spectrums. And in the y-axis you can see that blue vertical line. It's showing that electronic transitions, if they will high, that will represent the oscillator strength. Every line height you can check. And when you go with this BDF XF orbital, you can check. Once again, you can visit our previous video. I have explained about each of the orbitals, what is the actual meaning. You can click like this. Transparency, it is showing that interactions or different files. You can also collect your files or image in here. So now I'm going to in here my tutorials. In this tutorial you have discussed about TDFT parameter of the naphthalene, but in another tutorial I will discuss about the spin orbital couplings, non-adiabatic coupling, optimizations, frequency. So thank you very much for seeing this tutorial, and who has not subscribed our channel, please subscribe Impulse Technology. Thank you very much.